Okay, let's just jump right in. What if everything we thought we knew about physics was fundamentally wrong? I mean, seriously. The source material we're diving into today proposes this truly radical idea that our entire view of the universe isn't just a little incomplete, it's completely backwards.
And really, this is the big question at the heart of our explainer today. What if our most basic, fundamental perspective on reality is just flawed? The argument we're about to unpack suggests that it is. And if that's true, the implications for the future of science are just absolutely massive.
So you might be wondering, why even ask such a wild question? Well, because let's be honest with ourselves. Fundamental physics kinda seems to have hit a wall. For all the incredible progress of the last century, our current theories just can't seem to crack the biggest mysteries out there.
I mean, think about it for a second. A unified theory of everything, the nature of dark matter, the whole quantum measurement problem, we're stuck. And the core argument here is that this isn't just some temporary roadblock. It's more like a giant, flashing neon sign telling us that our entire conceptual framework, our very way of thinking about physics, is the real problem.
And this is where we get to the core critique. The argument isn't that the universe is broken or weird, it's that our two main theories for describing it, quantum mechanics and classical physics, they aren't objective descriptions of reality at all. They're powerful for sure, but ultimately they're just reflections of us.
Yeah, and this slide really lays out the whole problem perfectly. It's like we've got two completely different rulebooks for reality. Down at the quantum scale, things get fuzzy. Nature protests when we look too closely. Its properties become dependent on our act of measuring them. But up here at our scale, the classical view works just fine. The crucial point, though, is that both are just perspectives. They're not the full picture, not even close.
But the critique doesn't even stop there. Oh no, it goes after the very language we use to write the laws of physics, mathematics itself. The source material puts forward this really stunning claim. Our belief in a purely mathematical universe is, itself, a fundamental mistake.
This is a direct quote from the source, and wow, is it a powerful one. For decades, the holy grail for so many physicists has been this idea that reality at its deepest level is math. This idea right here challenges that to its very core. So why? Why push back against mathematics, the one tool that has been so incredibly successful in science? Well, the reasoning cuts right to the heart of what math actually is, and more importantly, what it isn't. So here's the thinking. The universe can't be pure math because math is a human invention. It's an unbelievably powerful tool, don't get me wrong, but it's a tool that only approximates reality. It's not reality itself. And so, to build our entire understanding of the cosmos on what the source calls a corrupted mathematics, well, that's a massive gamble that we're pretty much destined to lose.
Okay, so if our perspectives are warped and even our math is suspect, what's the alternative? Where do we go from here? This brings us to the proposed solution, a brand new foundation for reality based not on abstract equations or points of view, but on a single underlying physical material.
And this is the core idea, a unified material framework. So instead of starting with different rules for different scales, this model starts with one single objective material. And from that one foundation, everything else we see is supposed to just emerge, both the quantum world and our classical everyday reality.
So how on earth can one thing create two such different-seeming realities? Okay, let's walk through it. First, you start with one universal material. Simple enough. Second, at our human scale, that material behaves in a way that lets us see distinct, separate objects. That's our classical world. But, and here's the kicker, step 3, when we try to probe that exact same material at the tiniest scales, it protests. And that protest is what we call quantum mechanics. The material literally resists being pinned down. Its properties become probabilistic until we measure them. So you see, it's not two worlds, it's just one material reacting differently to how we look at it.
So what's the point of all this, right? If we adopt this new framework, what can we actually achieve? Well, the ultimate goal is to create what the sourcer calls a true machinery-driven physics, a set of laws that describes how the universe actually works underneath it all.
And the payoff here could be absolutely huge. I mean, just imagine. A truly objective model of reality that exists whether we're looking at it or not. A clear path to finally unifying the quantum and classical worlds. And a brand new trajectory to tackle those big questions that have left us stumped for decades. This is about building a physics that describes the machinery of the universe, not just our limited view of it.
And that leaves us with this final, crucial question to chew on.
Is our science describing the universe as it truly is, or is it just describing a really sophisticated reflection of ourselves? The material we've explored today argues it's the latter and offers a radical, exciting new path to maybe, just maybe, find out what's really out there. Thanks for joining me.